Okay, so this is the rational root theorem. And how you've used, basically the rational root theorem is P over Q. And how we find P is the factors of the constant term, and Q is the factors of the leading coefficient. And the reason that there's a line there is because it can be a fraction, okay? So what we're gonna do is we're gonna do two stages. The first stage is where we're gonna find all the possible rational roots. It is called the rational root theorem because it only finds the rational roots. There could be imaginary roots, but you can't find those until you know all of your rational roots. So we start with rational roots first. So the first two examples are just going to be, let's find our possible roots, okay? So here we go. So the instructions would be, find all the possible. Notice the word possible, okay? It doesn't say find the roots. It says find all the possible rational roots. Okay, and so here is the problem. It's g of x equals 3x to the third minus 4x plus 10. Okay. So remember that the leading coefficient is the number that's in front of the variable with the highest exponent. And remember, it always has to be in standard form. It's why yesterday, every time we wrote something, I'm like, you need to write it in standard form because you need to make sure that it's in standard form so you know which one is the leading coefficient. So what is the constant? So before we start listing the factors, we need to determine the constant and the leading coefficient. So P is the constant term. So out of these three terms, which one is the constant? 10 is the constant. Okay, so now before we get to Q, let's do 10. Let's list the factors of 10, okay? So the factors of 10 start with 1. And factors are going to come in pairs. They always are going to come in a positive and a negative, always. So I know that 1, I know that 2, I know plus or minus 5, because 2 times 5 is 10, and then plus or minus 10. They don't necessarily have to be in order from smallest to largest. It's just usually, let's be honest, when we go to factor something, it's usually the smaller numbers, correct? But again, in first period, I had 1, 10, 2, and 5. It's not going to really matter. Okay, now what is the leading coefficient? 3. So now I want to list the factors of 3. And what are the factors of 3? Plus or minus 1, plus or minus 3. Now that is nothing. That all we did is we listed the factors of P, we listed the factors of Q. Now what we need to do is now we're going to list our possible roots. So here are our possible roots. To find our possible roots, we are going to put P over Q. So what that means is, I'm going to start with P. So P is plus or minus 1 over plus or minus 1. What is that? 1. So plus or minus 1. Remember, anytime you do your possible roots, you're never going to get rid of the plus or minus, okay? And then I'm going to go with 2. 2 over 1 is 2, right? Plus or minus 2. Then I'm going to do 5 over 1, which is plus or minus 5. I'm going to do 10 over 1, which is plus or minus 10. So that took care of the 1 at the denominator. Now I'm going to have a denominator 3. 1 over 3. Does that reduce? Does 1 over 3 reduce? So we're going to write plus or minus 1/3. Now we're going to do 2 over 3. 2 over 3 does not reduce, so I'm going to write 2 over 3. 5 over 3 and then 10 over 3. So those are all of my possible rational roots, okay? That doesn't mean that they are all going to work, but those are my possible roots, rational roots. So again, I put P, Q, I listed the factors of P, I listed the factors of Q, and then I did the fractions. 1 over 1. And some people like to go 1 over 1, 1 over 3, 2 over 1, 2 over 3. You can do that as well. I always like to leave my fractions last because I don't like to test fractions if I don't have to. Okay? Let's do example 2. So tonight on your homework, I think I gave you 3 of these and 3 of the next examples. Okay, so we're going to find all the possible rational roots again. And it's h of x equals x to the third plus 11x squared plus 24. So just like we did before, what is the constant term? Because p is always the constant term. So what is p? Is it 1, 11, or 24? 24, because that's our constant term because it has no x. And then what is our leading coefficient? 1. Okay, let's list the factors of 24. Remember, when you go to list them, you always put plus or minus in front. So what's the first factor of 24? Plus or minus 1. What's the next one? 2. 3.
4. 6.
Okay.
8. And then 24. 12.
12. And then 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Perfect. Okay, what are the factors of Q? Okay. Now, this is the great thing. When Q is 1, right? Basically, you already know your possible factors. And it only works when Q is 1. When Q is not 1, you're going to have fractions. Well, sometimes you'll have fractions. So 1 over 1 is 1. 2 over 1 is 2. And you can see 3 over 1 is 3. 4 over 1 is 4. 6 over 1 is 6. 8 over 1 is 8. 12 over 1 is 12. And finally, 24 over 1 is 24. So when Q is 1, basically your possible roots are whatever P is. It's kind of nice when Q is 1. Will there be ones that I give you where Q is a fraction, where Q is a number? Yes, and you might have to test a fraction, but Miss Chasey and I have agreed that if that happens, we'll tell you, you might want to test this one. Now, when we use the rational root theorem, the reason we do this is because we're going to solve it, you guys. We're going to find the roots. So on 5.7, there were three problems that I had you that are sitting there, and I said we'd go over them. You can use the rational root theorem to do those. Okay, that's on 5.7. 5.7 just has you guess and check, and we decided that we didn't really want to do the guess and check. We wanted to teach you the rational root theorem. So there's two possibilities. It's going to say find all the rational roots, or it's going to say factor or find the roots. So example 3 now is going to be find all roots. And remember, roots are also zeros, okay? And the problem is going to be x to the third minus 6x squared minus 13x plus 42. Now, you guys, some of your roots will not be rational. Some of them will be irrational. But what we do is we start with our rational roots. So again, not all of our roots will be rational, but we're going to start with our rational roots first. So everything that we do, anything that I give you from right now, is going to have at least one rational root, okay? And we'll get down, when we get down to the second part, you'll see what I mean. Okay, so we're gonna start just like we started the last one. We're gonna list all of our possible roots because we have to have something to test. Okay, so what is my P? 42. What is my Q? It is 1. So this means whatever I write down basically are my roots that I'm going to test. Because if Q is 1, we're not going to have any fractions. So here are my possible roots. Okay. Again, the reason I'm going straight to possible roots is because Q is 1. If Q was not 1, I couldn't do this. Okay, so what are the factors of 42?
1.
Okay.
2.
2.
3.
4 does not go into it.
6.
6 goes into it.
7.
14. 21 and 42. Okay, now, here's the cool thing. If all of our roots are rational, then they're here, okay? So remember, you guys, 1 times 42, 2 times 21, 13 times 14, 6 times 7 is 42. Okay, so now we got that, but we have to test it. So what we're going to use is we're going to use synthetic substitution. And synthetic substitution is where we are going to take our possible roots and we're going to test them. In order for it to be a root, what does the remainder have to be? It's the remainder theorem. So what, in order to be a factor, what does the remainder have to be? 0. If it's not 0, it means it's not a root. So we're going to test our roots. So here's the other thing. Usually you're going to find your root within between the 3 and 5 numbers, right? Well, 1 and 5. It's within the first 5 numbers you test, you should be able to find your root. Okay, so what I mean by testing is I'm going to test 1. So what that means is I'm going to replace, wherever I see an x, I'm going to put a 1. So I'm going to put 1 to the third power minus 6 times 1 to the second power minus 13 times 1 plus 42. And I want to see what my remainder is, or what my answer is. If I get an answer of 0, that means I'm done, and I'm done testing, okay? So I need you guys to test that one and then tell me what you get. Okay, so I got 24, which means that is not 1. So that's not a root, okay? You guys, if it was a root, it would be 0. So now we're going to test negative 1. So what that means is I'm going to replace x with negative 1. You guys, this is where you just need to persevere. Just because you're going to have to work it. You're going to have to work a little bit. And again, within the first 5 numbers that you test, you should be able to find your root. Just so you know, if the constant term is negative, it doesn't change your possible roots. Your possible roots will still be plus or minus. The negative is not going to matter if your constant is negative. Okay, so test -1 and let me know what you get. Okay, so this is 48. That is not 1. Well, crap, right? So now let's test 2. And let me know what you get. So you guys, you just have to keep testing. And notice I started with the +1, -1, 2. There's some kids that they test all their positives first and then they test their negatives. I like to go positive, negative, so I know I've taken care of that, okay? So I got 0. That means, yay, we found our first root, okay? So now what we're going to do is we're going to use that synthetic division that we learned, and we're going to test 2. Now, we already know that 2 is a root. Do you remember before I would give you the root, and I would say, hey, this is a root, so it means you should get your remainder as 0? Again, you guys, you just told me that this is a 0, so when we're done with synthetic division, our remainder should be 0. So, just a reminder, the coefficient in front of x to the third is 1, then I write -6, then I write -13, and I write 42. I bring down the 1. 2 times 1 is 2. -6 plus 2 is -4. 2 times -4 is -8. -13 and -8 is -21. 2 times -21 is -42. And I get 0. So, perfect. Now, what I'm going to do is I'm going to write this. I'm going to write my new one, which is x squared minus 4x minus 21. There are 2 things you can do at this point for a quadratic. You can either try to factor it, or you can use the quadratic formula. Either one works, okay? So if you're like, I don't even want to factor it, I'm just going to assume that it's unfactorable and I'm always going to use the quadratic formula, go ahead. But because a is 1, I'm going to see if it's factorable. And what that means is, can I find 2 numbers that when I multiply I get -21, when I add I get -4? So my factors of 21 are 1 and -21. And negative, let's see, it's going to be 3 and -7. And the reason that I made the larger one negative is because the answer was negative. Well, 1 and -21 does not work, but this one works, doesn't it? So I'm going to factor it as x plus 3 and x minus 7. And remember what the problem asked you for. It said, find all the roots. Well, what was the first root that we got? You already told me what the first root was. What was it? It's the one that we tested. 2. These are factors. I need to know the roots. So yesterday we learned that if it's positive inside, what was the root to start with? This is -3. This is +7. We have 3 roots. Our exponent was 3, so all of our roots were rational. That's our answer. So yes, you have to test, synthetic division, factor, or use the quadratic formula. So that takes us up to example 3.